All right, let's finish up our review with graphing parabolas. Okay, so the first thing to ask is what form this is in. So we're going to check our forms. We have vertex form, standard form, and intercept form. This one is in vertex form. We see parentheses and then squared. So some quantity squared. All right, so this one's in vertex form. The nice thing about vertex form is it literally gives us our vertex, right? If we're looking at the form a times x minus h squared plus k, hk is our vertex, we know that. So I take the sign, I take h, which is the opposite sign, so it's positive 6. And then k, we keep the sign for, so it's negative 3. The vertex, everything centers around the vertex. Okay, so that's the most important part. Okay, and then we have some shortcuts here. The axis of symmetry is x equals whatever the x part of the vertex is. If the max or min value is whatever k, the y part of the vertex is, but we need to choose if it's a maximum or a minimum. If a, okay, so here a is 2, that's our stretch. If there's a negative in front of a, then we have a parabola that opens down, and then if there's a positive, it opens up. If it opens up, that means the vertex is your minimum. All right. Let's graph the rest of them. So I use A to help me find the rise. So 1 unit away from the vertex, I will rise A amount of units. 2 units away from the vertex, I will rise 4A. So 8 units. So from the vertex, go to the left 1 and rise 2. Go to the right 1 and rise 2. Go back to the vertex, go to the left 2 and rise 8. Go back to the vertex, 2 to the right, and rise 8. Parabolas that open up or down, the domain is always negative infinity to positive infinity, all real numbers. And your range, if you have a minimum, it starts at the minimum and goes to positive infinity. So negative 3 has to have a bracket because it's literally the vertex. It has to be a part of your domain, your range, sorry, all the way to positive infinity. All right, let's look at number 11. So we want to check what form this is in first of all to see what we need to do. Okay, so when you have absolutely no parentheses, it's all timesed out like that. Looks like we're in standard form. Okay, where I can see we have an x squared term, an x term, and then a number term. Same here. So we will label this as standard form, and that will give us all the information that we need. Okay, so for standard form, the vertex is not given just straight out like vertex form. So to find the h, the x part of the vertex, you will do negative b over 2a, and then to find k, the y part of the vertex, just plug in h into the function, and you'll get out k. So negative b over 2a is h. h equals, sorry, I'm going to label a and b over here. So a is the number in front of our squared term, which is negative 1. b is the number in front of our x term, which is positive 10. So h is negative b, so if it's positive 10, then it's now negative 10 over 2 times a, which is negative 1. Negative 10 divided by negative 2 equals 5. That is the x part of my vertex, also my axis of symmetry. Okay, to find k, I need to plug in 5 into the function. So the function is negative x squared plus 10 times x minus 21. And those x values are 5, right? Because that's the x part of the vertex. 5 squared is 25, but then drop the negative in front, so negative 25 plus 50 minus 21. Put that on a calculator and you get 4. So the vertex is 5, 4. The axis of symmetry is x equals h, which is 5. A is negative, so we're opening down, so we have a maximum value this time. That maximum value is k. Let's graph it before we write our domain and range. 1 unit away from the vertex, we will rise a units, which is negative 1. 2 units away from the vertex, we will rise 4 times a. So negative 4. 1 unit to the left, I go down 1. 1 unit to the right, I go down 1. Back to the vertex. 2 units to the left, I go down 4. 2 units to the right, I go down 4. Domain for all parabolas that open up or down is negative infinity to infinity. The range for this one, since this one opens down, the range is all the way from negative infinity all the way up to our maximum value. So negative infinity has a parenthesis around it, but your maximum value is right here. It's stated as 4, and it needs to have brackets because it is part of the vertex. It is definitely a part of the range. The last one I'm going to do is this one right here. Again, we need to figure out what form it's in to find the vertex, and this is in parentheses right here, parentheses right here. You have x minus p, x minus q, and then a in the front. So this is intercept form. All right, to find the vertex in intercept form, we take p plus q and divide by 2. Okay, so p is the answer you get when you use zero product property. So your x-intercepts, literally. Okay, so if I were to use zero product property, 0 is equal to 1/2 x minus 5, x minus 3. To find my x-intercepts, which I know the y value is equal to 0 on the x-axis, then it would say x minus 5 equals 0 and x minus 3 equals 0. So x could equal 5 or x could equal 3 when you add the 5 and you add the 3 to both sides. So keep in mind that for p and q, you still change that sign, okay? Kind of like in h, in our vertex form. So p is 5, q is 3, and then a is 1/2. Those are the important pieces that are going to help us find the rest of this over here. So h, the x part of the vertex, is p plus q over 2. So 5 plus 3 divided by 2, that's 8 over 2, which is 4. So to get the y part of the vertex, we plug in 4 for the function. So k is equal to 1/2 x minus 5 times x minus 3. And my x value is 4, so I'm going to plug in 4. Remember to do the parentheses first, so 1/2 times 4 minus 5 is -1, 4 minus 3 is 1. 1/2 times -1 times 1 is -1/2. Okay, so we're going to have a fraction. Don't freak out. All right, 4 -1/2. So I go to 4, and then I'm not even going to go down a whole unit. I'm just going to go halfway, which is basically covering up the 4 on the graph. Okay, so that's my vertex. My axis of symmetry, x equals h, so x equals 4. Am I opening up or down? A is positive, so we're going to open up. So we have a minimum value, so circle the minimum. and the minimum is -1/2. That's the lowest it goes. All right, let's do our rise before we do our domain and range, just because it's much easier to visualize. 1 unit away from the vertex, we will rise a units, which is 1/2. 2 units away from the vertex, we will rise 4 times a, which is 4 times 1/2, which is 2. So I'm going to go to the left 1, and then halfway up, which is actually right on the x-axis. Go back to the vertex, right 1, and half a unit up. Go back to the vertex, 2 units to the left, and then 2 units up. You're going to be in between, okay? That's in between 2 grid lines. And then reflect that point over here, because you know it's symmetrical. Nice. All right, so our domain for an up or down parabola is -infinity to +infinity. And our range has a minimum value, so you start off with k 4 all the way up to +infinity. Now, without actually doing the next one, I just want to show you that this could be in intercept or vertex form. It looks a little closer to vertex form like you're used to. So and vertex form is generally easier because it basically gives you the vertex. But if I wrote out, this is -1/3. If I wrote out x minus 3 times x minus 3, you see that I actually have the same look as intercept form, right? So since they just condensed it, took those 2 and said, oh, that's just the same as x minus 3 squared, then now it looks like it's in vertex form, but it still is the same as this one also applies to, it is also in intercept form. So either form would be allowed. All right, that's it.